Today we'll be graphing sine and cosine waves. We'll be talking about period and amplitude. Later we'll add phase shift. So let's see, let's get me out of the screen. And if we were in class together, I'd have you help me create a t-chart for y equals sine of x. And I'd ask you to plug in a lot of the values, those special angles that we're familiar with. And I'd have you type in your calculator, and you'd find that they would all fall. Like here, the sine of 30 is half, the sine of 90 is 1, the sine of 120 is half. And when you sketch this, we would have this beautiful sine wave. So, a couple key things to understand about sine wave is that it begins right here at the origin. And this is going to be key when we start graphing a cosine wave in a little bit. Now let's go ahead and fill in some of this information down here. Domain, remember, is side to side. And we should note that that sine wave continues into infinity. So in set notation, how do we say all real numbers? Just like that. Interval notation would look like, and remember we've got the curved parentheses and not the square brackets because we can never equal infinity. Now our range is on the y, right? Really tiny here, but you can see it maxes out at 1, and it bottoms out at -1. So in set notation, in this time, we can equal it. It's in between -1 and 1. Interval notation, -1 and 1. Some of you are familiar with waves, whether it be sound waves or otherwise. And the amplitude has everything to do with how tall is that wave. And so when we're talking about amplitude, we're looking at distance from center. So here we are at 0. It has an amplitude of 1, right? Even if I went the other direction, and we're talking about distance from center, so it's going to be a positive value. The amplitude is 1. So how far from center? And it's always positive. All right. Now let's look at the period. Period means how long is one cycle. Now if you were to look at this and continue, it would do an exact wave that looks just the same. So from here to here is one cycle, and then it repeats itself. So let's see, from 0 to 360 degrees. Now it could ask for radians too. So if you need to remind yourself that that is 2 pi, and here is pi halves, go ahead and go through and mark those if you need to, all right? So there is our sine wave. Now let's look at our cosine wave. Let's see here. Cosine wave looks so very, very similar, doesn't it? Key difference is, rather than starting at the origin, it starts at the maximum value. All right, so let's go ahead and look at this then. We have a maximum, we have a minimum, we have a maximum, right? Domain, side to side. We're going to have all real numbers. And then interval notation, all real numbers. All right, our range, again, I wrote right over that one, but you can see the negative one there. So our set notation is we are in between -1 and 1. Okay, and our amplitude. Remember, we're talking about how far from center? Our amplitude is 1. And what's our period? How long does it take to do one cycle? Okay, we're at the peak here, we're at the maximum, and we're back at the maximum here, which is 360 degrees or 2 pi radians. And I should have put that over here on my sign, 360 degrees or 2 pi radians. Now, if I just asked you to graph sine and cosine waves over and over, that would be so easy, right? Because they would look the same every time. And so we are going to change the amplitude and the period. All right? So you'll notice I've got a value here in front of sine. And then I have a value here in front of the x. And here it explains what they are. A is my amplitude. And B helps me figure out my period. So 360 divided by B, or if we're in radians, 2 pi divided by B. That's how I figure out my period. All right, look at this guy. How come it's not that long, elegant curve that we graphed just a second ago? Well, let's see. What happened here? What's going on here? Let's figure out the period. This is in degrees, so I'm going to go in degrees. 360 divided by 4 is 90. That means every 90 degrees you have to have one complete sine wave function. Starts in the middle, high, low, ends in the middle. And I believe you're going to be working in radians frequently today. So let's say, or 2 pi divided by 4 is every pi halves. All right, so let's look at this. 0, 90. Here we go. One sine wave. I'm going to grab my highlighter. That's not graphing very well. Let's see. There is one cycle of that sine wave in 90 degrees. And what's the amplitude? How tall is it? Well, without even looking at the graph, I can tell that the amplitude is 3. Excuse me. Okay, so coming over here, find the period and amplitude of each function. All right, how do I find the period? 360 divided by the number in front of our x or theta in this case, which is 180 degrees, or if you're working in radians, 2 pi divided by 2, or every pi radians. Okay, and let's do this one. Period. Whoops, I forgot the amplitude, didn't I? Amplitude. How tall is it? 1/2. All right, period here. 360 divided by 3 is 120 degrees, or 2 pi divided by 3. That doesn't reduce, so just 2 pi over 3. And my amplitude is 3. All right, we're going to go ahead and we're going to sketch this one. Remember, a sine wave starts in the middle, goes high, crosses the middle, goes low, and it's back to center. You'll find me doing that frequently. And where does it start? At the origin. All right, so let's do that. We know we're going to end here, and I have one full cycle every 120 degrees. So I'll come over here. So here is my beginning. Here is the end of one cycle. And then you'll find that we're just going to split this in half and then split it in half again is the easiest way. So we're at midline, at the beginning, at the ending, and also right in the very center. So split that in half. All right. And now I need to look at my amplitude. It has an amplitude of 3. So we go to the highest point in between here. Yes? So halfway, I have an amplitude of 3. And then I have my low point, which would be halfway between here. I need to go a distance of 3 again from center. And then here we go. Now, because I have room on this, you should do it again. Fill out your graph. All right. When we graph on the computer, it'll make it a little bit easier and it'll do it for us. So there's that nice, elegant sine wave. All right. Now let's take a second and let's graph cosine, looking and changing the amplitude and period. Okay, same thing. The A tells me the amplitude, the B affects the period. All right, so what is the amplitude of this one? 3. What is the period? I am also going to put here, or 2 pi divided by B. All right, 360 divided by 2 is 180 degrees, or 2 pi divided by 2, or every pi radians. Okay. Period and amplitude of this. Period is 360 divided by 3, which is 120 degrees, or 2 pi divided by 3 radians, 2/3 pi radians. The amplitude is 2. Cosine, period. Let's see, what's in front of theta right now? It's a 1. So 360 divided by 1, or 2 pi divided by 1, we have 1 cosine cycle every 360, or 2 pi radians. And what's my amplitude? My amplitude is half. All right, let's remember what our cosine wave looks like. It starts at the maximum. Halfway through, it's crossing at the center. It goes to the minimum, and then it's back to the center. And then it is back at the maximum at the end of its cycle. Okay, so max, center, minimum, center, max. So I've got to graph this one here. I have an amplitude of half, which puts me right there, yes? And -1/2 would be down there. Where does my cosine wave start? At its maximum. One full cycle would end back at its maximum, and that is every 360 degrees in this case. So let's see here. All right. At halfway, I need to be at the lowest point. So at 180 degrees, that would be here. And then let's split those distances in half one more time. We would be at center and at center. and then graph that nice cosine wave. And this does continue in the other direction. All right. Okay, I will do a separate video showing you how to do those problems on Alex.